Audible? Am I audible?
Yes, sir.
Screen share is visible. Screen share.
Yes, sir.
Okay. So the last portion in module 5 is the reservoirs. So in the previous class, we have discussed about the channel design by Kennedy's method and also the Lindsay's method of channel design. And the last portion in the module 5 is reservoirs. So all of you know what is a reservoir. A reservoir is a large artificial lake created by constructing a barrage or a dam across a river. And the term reservoir in water resource engineering is used in a restricted sense for a comparatively large body of water stored on the upstream side of a dam constructed for various purposes. So the purpose of constructing a reservoir is to cater water for different purposes. So if a reservoir serves only one purpose, then such a reservoir is called as a single purpose reservoir. So on the other hand, if it serves more than one purpose, so it is a multi-purpose reservoir. So these are all the definitions already you know about it. And so the various purpose normally served by a multi-purpose reservoir. So one basic water requirement, the most of the water is required for the irrigation activities, and also the water, some portion of the water is required for municipal and industrial water supply, and some portion of water will be treated as a flood control because the excess water has to be released from the reservoir, so which acts basically as such reservoir acts as a flood control reservoir. Only in case of high stage of flow, the water can be stored in the reservoir. And the same water can be disposed on the downstream side without causing much damage on the downstream side. These are called as the flood control reservoirs. Next is can also be power generation and navigation, recreation, development of fish and wildlife, soil conservation, pollution control, and mosquito control. So the various purposes of a multi-purpose reservoirs are the following. The types of reservoirs, depending upon the purpose of the reservoirs, may be broadly classified into a storage reservoir, a flood control reservoir, a multi-purpose reservoir, a distribution reservoir, and a balancing reservoir. What are the different types of reservoir? So storage reservoirs are also called conservation reservoirs because they are used to conserve water. So next one is the flood control reservoir. So a flood control reservoir is basically constructed for the purpose of flood control. It protects the area lying on its downstream side from the damage due to flood. So the third type is the multi-purpose reservoir. A multi-purpose reservoir is one designed and constructed to serve two or more purposes. So most of the reservoirs are designed as a multi-purpose reservoir to store water for irrigation and hydropower and also to affect flood control. So because if a reservoir serves many purposes, then it is said to be a multi-purpose, wherein the cost can be recovered by supplying water for various purposes. So hence the cost of construction can be recovered in case of multi-purpose reservoir because we get back the whatever the investment that has been made. So generally the reservoirs are basically designed and constructed to serve more than one purpose, that is multi-purpose reservoir. Next, some of the reservoirs are distribution reservoirs. A distribution reservoir is a small storage reservoir to tide over the peak demand of water for municipal water supply or irrigation. Because whenever there is a high stage of flow in the river, so that water cannot be diverted directly. So in such a case, you may have a small reservoir wherein the excess water can be stored here and the same water can be diverted for the municipal and irrigation activities. So next one is the balancing reservoir. A balancing reservoir is a small reservoir constructed downstream side of the main reservoir for holding water released from the main reservoir. So this balancing reservoir is also used for power generation because in case of powerhouses, we require the head of water, so constant head of water in order to have an efficient power generation. So in such cases also, we use these balancing reservoirs. Next, we know what is the definition of a reservoir, the various types of reservoirs and their purposes for which they have been constructed. And before we take up any reservoir project, so some of the following investigations have to be carried out before selecting a particular place for a reservoir. So these are some of the following investigations are the engineering investigations to be carried out in order to have or in order to fix a particular place for reservoir location. Now, the following investigations are usually conducted for reservoir planning. So first one is the engineering survey. So engineering survey basically include the surveying of the entire area, preparing the area map and the corresponding contours of that particular area. So engineering survey basically include the area is entirely surveyed based on the engineering applications like finding out the relative levels and also the contours of that particular area. So all these information will fall under engineering survey where a detailed survey is being carried out and the map is prepared. So thereby we can locate the exact place to have a proposed reservoir. So engineering survey is a first survey that is also called as recurrent survey. So next is the area in which the dam has been proposed. The geological investigation plays a very important role because it gives the information about the water tightness of the area, And also, in order to have any reservoir in a particular place, we need hydrological data. What is the volume of water that comes out of the catchment area? So that depends the height of the reservoir, and also the length of the reservoir. So now here, these are the three major investigations that has to be carried out in order to have a suitable place for a multi-purpose reservoir. Now, so the engineering surveys are generally conducted for the dam, the reservoir and other associated works. So generally the topographic survey of the area is carried out and the contour plan is prepared. And from the plan, the following physical characteristics are prepared. So you have done a new time project in your extensive survey project. So wherein just you have selected a place. Correct? You have selected a place for constructing the new tank. Then you have calculated the height of the new tank to be constructed, and you also have carried out the contours on the upstream side of the new tank, so that you will get the area, and also the depth, which gives the volume of water to be stored on the upstream side. And you have also carried out the canal alignment and right bank and left bank. So you have proposed a new tank in a particular place, but before selecting a particular place for any reservoir structure, so these three investigations are must. That is, one is the engineering survey, wherein we are going to prepare the topographic map of that particular area. And also the engineering survey gives knowledge about the area elevation and storage elevation, because this is most important. So a reservoir should store sufficient amount of water to cater whatever the demands on the downstream side, whether it is a single purpose reservoir or a multi-purpose reservoir. So area elevation and storage elevation are very important. So it gives the contours of that particular area. So the reservoir capacity or the volume of storage can be decided on the area elevation and storage elevation curves of that particular area. So now, under engineering survey, we have certain equations to find out the area elevation and storage elevation. And here, these are some of the equation by which we can calculate the total volume of water that can be stored on the upstream side of the reservoir. The first one is the trapezoidal formula. It is of the form sigma h by 2 a1 plus a2. So here these are the areas, and h is the height of water. So thereby we will get the volume of water that can be stored by using the trapezoidal formula. And also we have one more formula that is known as the cone formula. Cone formula, it is of the form V is equal to h by 3 a1 plus a2 plus square root of a1 a2. So these are the two equations by which we can calculate the volume of water that can be stored on the upstream side of a reservoir. So these data we get it from the first survey, that is the engineering survey. So next is the geological investigation has to be carried out thoroughly because it gives the information about the water tightness of that particular area. So geological investigations of the dam and reservoir site are done for the following purposes. First is suitability of foundation for the dam and the water tightness of the reservoir basin. And because if the area is very weak, then what will happen? Whatever the water stored on the upstream side, so will be wasted in deep percolation under the body of the reservoir. So water tightness of that reservoir basin and location of the quarry sites for the construction material, because the reservoir construction require a large number of materials. So if the quarry sites are very near to the proposed area, then the cost of transportation of the materials will come down, and hence the cost of construction can also be reduced to some extent. Next, the groundwater condition in that particular area, so which is also very important. And also the type and depth of overburden. If there is any overburden surrounding that particular area, so those information will be also helpful, and also the location of permeable and soluble rocks, if any. So in any case, the reservoir should not be constructed on these permeable and soluble rocks area. So it has to be neglected. Next is the last investigation under reservoir investigation is the hydrological investigation. The hydrological investigations are conducted for the following purposes: to study the runoff pattern of the proposed dam site, and also to determine the storage capacity corresponding to a given demand. So basically, any reservoir mainly depends on the hydrological output of that particular catchment area. So which decides the volume of runoff, and also which decides the storage capacity of the reservoir for the various purposes, and also to determine the maximum discharge at the site. So generally the water comes out of the catchment at the concentration point. So where the maximum discharge can be measured. So based on this data, we can fix the height of the reservoir, including the freeboard. Right? So thereby we can store maximum amount of water if the hydrological investigation is carried out properly. So based on which the efficiency of the reservoir can be increased. Next is the following factors to be considered for the selection of a site for a reservoir. So these are some of the factors to be considered for the particular selection of a site for a reservoir. A good site for a reservoir should have the following characteristics. First one is a large storage capacity. The topography of the site should be such that the reservoir has a large capacity to store. The best site is the valley site, because you have two hillocks on the two sides, so that the cost of economical length of the dam also gets reduced. So the topography of the site should be such that the reservoir has a large capacity to store water. And suitable site for the dam. A suitable site for the dam should exist on the downstream of the proposed reservoir. So there should be a good foundation for the dam. The reservoir basin should have a narrow opening in the valley so that the length of the dam is small. So the cost of the dam is often a controlling factor in the selection of a site for the reservoir and also the water tightness of the reservoir. The geological conditions of the reservoir site should be such that the reservoir basin is watertight. The reservoir site having pervious rocks are not suitable. The reservoir basins having shales, slate, schist, granite are generally suitable. So granite is the best one. Granite and this. So these are the two rock formations which has more water tightness capacity. And also the good hydrological condition. The hydrological condition of the river, the reservoir should be such that the adequate runoff is available for storage, and the catchment area of the river should give high yield. So there should not be heavy losses in catchment due to evaporation, transpiration, and percolation gases. So these all they are the hydrological factors. Now, next fifth one is the characteristics of the reservoir is a deep reservoir. The site should be such that a deep reservoir is formed after the construction of the dam. A deep reservoir is preferred to a shallow one because in case of the shallow one, you have more evaporation losses, correct? Whereas in deep waters, the evaporation losses are less, and also the weed growth is also less. Next, small submerged area. The site should be such that the submerged area is minimum because whenever we construct a reservoir, the upstream side of the reservoir it becomes an artificial lake so that the lands on the upstream side may be submerged, even the forest land or the people agricultural land. So the area of submergence should be as far as possible very minimal and low silt inflow. So the river which contributes to the reservoir should carry minimum amount of silt, but you cannot avoid, but you can have some silt ejectors at the source of the silt so that the entry of the silt into the river can be minimized to a certain extent. Next, no objectionable minerals. The soil and rock mass at the reservoir site should not contain any objectionable soluble minerals which may contaminate the water and also it may cause some problems to the physical structure of the reservoir. Next is the low cost and real estate. The cost of real estate for the reservoir dam, dwelling roads, railways should be as far as to be minimum. Now these are some of the factors to be considered for a site for a reservoir. So these are the factors which are self-explanatory. Now, this figure shows you the various storage zones of a reservoir. Now, this is the cross section of the reservoir, and this is the spillway gate through which the water is released on the downstream side. And also, you have a sluice inside, a sluice in the body of the reservoir. So now you can see here, this is the sluice where now these are the lines, dotted line shows the various water level in the reservoir. So the upper one is the maximum pool level. So this is also called as MWL, or the maximum water level. Next is you have another dotted line, so which is called as retarding pool level, or it is also called as the minimum pool level and maximum pool level. Now, below this returning pool level, you have one more dotted line, so which is known as the normal pool level. Now, the portion between the maximum pool level and minimum pool level, so this portion is known as surcharge storage. So this cannot be stored in the reservoir. It has to be disposed of through the spillway. So the portion of water between returning pool level and maximum pool level is called as surcharge storage. So which cannot be stored in the reservoir, which has to be disposed of. Now the portion of water between the returning pool level or minimum pool level and the normal pool level. So this portion is reserved for the flood control storage in case of any excess flood. So this portion can is also not utilized. See, this portion is left for flood control storage. Next, from this normal pool level to the minimum pool level. So here, instead of this is maximum pool level, let us call this as retarding flow pool level. So because this portion cannot be stored in the reservoir. So you have a line over here, so which is known as the minimum pool level. So the portion of water between the normal pool level and the minimum pool level is called as the active storage or useful storage. So this amount of water can be utilized for the various purposes. So the portion of water between the normal pool level and minimal pool level is called as the live storage. Live storage are also called as active storage or useful storage. Now, you have some portion of water that is below this dotted line, so which is known as the dead storage. So this portion cannot be utilized for any purpose. It has to be remain in the reservoir for the stability criteria. So usually the 10% of the total height of water is treated as a dead storage. So this picture shows the various storage zones of the reservoir. It is the upper one is the maximum pool level. So next is returning pool level. So this portion is the subcharge storage, so which has to be disposed of. And the flood control storage. This is the area between the normal pool level and returning pool level. So this area is, or this portion is left in the reservoir for flood control purpose. And the water level between the normal pool level and minimal pool level is called as the live storage, so which can be used for various purposes through a network of canal system. And below this, it is a dead storage, and here whatever the sediments that is present in the water that flows into the reservoir will be deposited at the bottom of the reservoir. So as far as possible, the rivers which contribute high percentage of silt, there itself, at the entry itself, the silt has to be removed. If not, the whole reservoir gets silted up within a short period of time, and hence the efficiency of the reservoir goes down because the storage level gets affected. So when the reservoir is fully sedimented. So okay, so from Monday onwards you have the second sessionals. So the portion for the second sessionals is the module 3 and module 4. I think Chaya Madam has shared you the notes in WhatsApp. So you have any doubts? Any clarification? Okay, so I'll be ending the class. So please mark your attendance. So again, we shall meet after the second internals next week. So till then, have a nice day. Goodbye. Thank you.